Welcome to Drone TV. I'm your host, Patrick Egan. And again, in a continuing effort to educate and inspire the unmanned aircraft systems community, we're going to talk about why we fly in the VLOS, or visual line of sight environment, and what that means and what you're actually doing. And what you're actually doing is deconflicting the airspace that you're flying in. And there's a lot of misconceptions about what VLOS means. Is it VLOS with my FPV camera and my goggles on? Is it, how far I can see my airplane? Well, it's none of that. It's, again, effectively how far you can see to deconflict the airspace between your unmanned aircraft system or hobby RC system and manned aircraft. So today's program is all about safety, and not bumping into one of these with one of these. We have to think about that. We're flying this, and you're flying it from the safety of the ground, and the people that are in this are in the air. So if we were to collide this with this, we would create an obvious safety hazard. We don't want to do that. You don't want to be the guy that's responsible for anybody else's, let's say, unsafe situation. And I think one thing that you want to really notice, and you could probably see this, is the field of view from inside the cockpit. This aircraft, I'm out here, and if I look out the side window, it's a low-wing aircraft, so my visibility is kind of limited here. I can kind of see out the front here. I have a range of view that I can see, and I can see straight out the window, but obviously I cannot see what's below me. So if an aircraft was coming at me from below, obviously from the sides, I would not be able to see it. From behind, or actually even up front, I have an extremely limited field of view there. We're going to use the Cracker Barrel to kind of show, use as an example of what you might see outside the window. Out there outside the window. And, again, it may not look too menacing, but again, this is impact range right there. From inside, you could kind of see, it was kind of a dramatization of how close the Cracker Barrel was in somebody's windshield. Of course, traveling at 100 knots, that's going to be all up in your grill pretty quick. Even the small amount of metal that is on this aircraft here could damage your prop. And, as we already all know, everybody balances their prop if you don't want vibrations in your photography. So you can imagine you don't want any vibrations in your aircraft when you're flying. It'd probably be a little disconcerting, you don't want that. You should probably go out and you can get yourself one of these. They're updated. You can see that. This one's from 22nd of August, 2013. But as you can see real quick here, this is the happy little burg of Sacramento. And we're actually right here. And you can see the kind of configuration of the runway. If you're following AC 9157, you're really not supposed to fly closer than 3 miles to an airport. So again, like any other map, it has a scale on it. You can figure out where that 3 miles is. You should probably stay out of that. That's how we used to do it before February 13th of 2007. You'd call the tower and say, hey, I'm going to be flying over here on Mulberry Street. Oh, really? Okay, yeah, you guys okay with that? Yeah, we're okay with that. Well, when are you going to fly? Well, we're going to be, we're going to be up at 11 and down at 11:15. All right, cool. Let me know when you're down. Okay, sounds good. And that was usually how the procedure worked. It sounds kind of casual or laissez-faire, but it did work. So in combination of talking to the people that are in control and finding out where you are on the map and what's around you, if there's a heliport or a landing strip or something else, this sectional will give you that information. And for $8, you're getting a lot of good info. And again, you won't be that guy flying in somebody's windshield. Things to think about. And I'm Patrick Egan, and from everyone here at UAS News, thanks for watching, and we'll see you next time.
Hello, I am Gus Calderon with ISIS Copters, and earlier in the episode Patrick was talking about how we share the airspace with full-scale aircraft. So when we're flying our multi-rotors and other unmanned aircraft, we really want to take a professional approach because we want to show that we can share the airspace and not have any conflicts with other aircraft. Now, I have a background in commercial aviation. I've flown professionally for about 18 years. And what I've tried to do is I've tried to integrate some of the safe practices that I've learned in commercial aviation into the operation of my multi-rotor and other unmanned aircraft. One of the most important things that I'd like to share with you is the use of a pre-flight checklist. This can really prevent a lot of problems from happening during flight, and it's something that I highly recommend. It takes just a few minutes to put together. And if you just take the time to do that before each flight, I think you'll find you'll have much more success when you're flying your multi-rotor. And also you'll be less likely to have any kind of safety incident or problem in the future. The first item on our pre-flight checklist is to inspect the battery. Very critical component of our unmanned aircraft system. So we first want to check to see if there are any swollen or damaged cells. You know, these batteries get transported from our home or our office to the field, and it's possible that they may have been dropped or damaged during transport. So really take your time and take a quick look at the battery. The other thing that I like to do, and I've learned from experience, is sometimes the solder joints can come loose or perhaps even disconnected from the connectors from being plugged and unplugged repeatedly. So you really want to just kind of gently tug on the solder joints at your connector, make sure that they're securely attached before your flight. The other thing that I like to do is I'd like to check the cell voltage on the pack before flight. A lot of us have many battery packs. We have some which are charged and discharged. Sometimes we're in a hurry when we're getting out to the flying field because we want to go and have some fun. But what I like to do is use a cell checker. You can get these from your local hobby shop or buy them online for around $10. And just put the cell checker on your battery right before your flight and just make sure that your battery, your LiPo is balanced, that all the cells have approximately the same charge, and you've got a full enough capacity for your flight. The next item on our checklist is to inspect the propeller. Now, I like to visually inspect each prop for damage, run my finger across the leading edge, make sure that they're all okay, that they have not received any damage. And the other thing which is very important to do is to check your prop adapter and make sure that your propeller is securely attached to your motor. I know this sounds like common sense, but there are many instances where if this gets overlooked and you have something coming loose, you can have a serious problem during flight. So I like to just go around and just double check and confirm that the prop adapter is securely attached to the motor. There are obviously many different types of prop adapters. This is a new style which came out, which I really like because there's basically no shaft at all and the prop is securely attached to the motor. So it actually takes out the possibility of the prop adapter being bent or damaged, and we get a nice smooth operation. We really want to make sure that each motor is moving smoothly, and as you know, there are powerful magnets in here and they can pick up metal debris, so I would go ahead and just kind of turn them freely. Take a quick look at all the fasteners on the airframe. Just you can run your fingers over the nuts and bolts, make sure everything is still on there, make sure nothing came loose. Personally, I like to use nylon lock nuts whenever possible, or thread locker whenever we have the opportunity to have a nice secure mechanical connection. I really recommend that. Let's take a look at some of the electrical connections. In particular, the main battery lead right here. Make sure, again, that you have a good solid solder joint between the wire and the connector. Sometimes these can come loose and that could cause catastrophic failure during flight. Nowadays, transmitters have become very complex. They're essentially computerized now. So we really have to take our time and make sure everything is set correctly. What I like to do is a physical inspection first. I like to move the gimbals around, make sure that there hasn't been any damage. A lot of times, or sometimes, transmitters may fall over, your gimbals may get damaged. So go ahead and do a physical inspection. Make sure all your switches are in the correct position. Now, multi-rotors have several different flight modes, so it's important that all your switches are in the correct direction before flight. I like to label all my switches, or at least the ones that I'm using for my flight modes. I highly recommend taking the time to label each switch so that we know before flight we're engaged in the correct flight mode and we won't have any problems or surprises during takeoff. What I like to do before I even do that is just look around, make sure the area is clear of spectators, and also make sure that the area where you're going to be taking off and landing is clear of debris. We don't want to have any loose objects or small debris damaging our propellers. So then what I like to do is connect the main battery, and just here's another little tip that I've learned from years of experience of doing this is I like to put Velcro on the battery itself. And then I like to also use straps to secure the battery so in flight it cannot slide at all, and we're going to make sure that it's not going to move as well during any maneuvering. And personally, I like to use 2 Velcro straps. This is something that's really critical, and we do not want to have any movement during flight. That could change our center of gravity and cause some serious problems. So we'll go ahead, strap the battery in, and then confirmed our transmitter is still on. We're going to go ahead and connect the main battery. Okay, now we've got light from our flight controller indicating what mode we're in. We've heard the ESCs are armed, and we're ready to move on to the next item on the checklist. I'd like to stand at least 20 feet away from the multi-rotor, and so we're going to step back. We're going to get into position. Lift off the multi-rotor, so it's just about at eye level, and when it's hovering at eye level, I want to take a look at it. I want to make sure that I don't have any unusual vibrations. I want to make sure that the platform is nice and stable. So before doing any maneuvers or taking it out, I highly recommend that you do that. Just take a quick look with the aircraft at eye level. So we're going to go ahead and do that. And you can see clearly we have a very stable multi-rotor aircraft right now. Everything seems to be working very well. So at this point I feel confident in maneuvering around and doing whatever kind of flying or filming that I plan to do. Okay, so this particular transmitter that I'm using, it's the Jetty model DS16, is an outstanding transmitter. And it has a feature called Telemetry. So basically there's a sensor on board the multi-rotor which is sending the current and the voltage down to a display on the transmitter. And this is very, very helpful for safety. I can monitor what's going on with the aircraft. You can see on this screen right here that at the moment I'm drawing about between 14 and 15 amps of current, and it's holding steady. The aircraft is hovering in a stable mode, so we would expect the current draw to be steady. Also on this right panel right here we can see the voltage, and I run on a 6S system, so I have a higher voltage than most operators, but you can see currently we're using 23.3 volts. Another really nice feature of this transmitter is the option to have voice enunciations of our telemetry. So it can be programmed to basically communicate the current and the voltage while we're flying, so we don't even need to look down to our screen. Here's an example right now.
Voltage 23.6 volts, current 0.7 amps.
In aviation, when we're flying real airplanes, we like to monitor what's going on with the motors, and we do this with consecutive flights. So I basically know that with this payload configuration right now, I'm going to be drawing around 15 amps. And so if I see a variation one day, that would lead me to know that there's perhaps a problem. And so it's invaluable information, and really, if you can afford it, if you have the means to get a system with telemetry, I highly recommend it. All right, so I'm going to go ahead and bring the aircraft in for a landing now. We want to confirm that the landing area is clear. We're just going to decrease the throttle. Okay, after we've disarmed the flight controller, the first thing we want to do after the propeller stops spinning is disconnect the main battery. So here's another tip I've learned from commercial aviation. It's really important after your flight to do a post-flight inspection. Not a lot of people think about this, but you really want to take a look at your aircraft right after you fly. Make sure it didn't incur any kind of damage that you didn't notice. And what I recommend on my checklist is I like to actually take the temperatures of the motors and the ESCs to see if there's any kind of abnormality. Now, you can do it just by touching each motor by hand, and they should relatively feel the same way. A better way to do it is to get a little infrared thermometer. These are very inexpensive. You can pick these up also at a local hobby shop or online. And you can take the actual temperature of the motors. That one's 65 degrees. This one's 58. That one's 63. And this is 60 degrees. So they're all pretty close. This is something really good to do because a lot of times if you see an increase in temperature, that would indicate that there may be a problem. Perhaps if a bearing is wearing out, or if you have a problem with the bearing, that's going to cause increased friction. That could raise the temperature of the motor. And this is something that you'd want to find out while you're on the ground and not in the air. The other thing you can do is you can check the temperature of your ESCs because you have a lot of current flowing through those as well. So again, you can use your temperature probe, and you can measure the temp of your ESC, and also you can check the temperature of your battery. So I highly recommend getting a little infrared thermometer. They're very inexpensive and can really help find some potential problems before they turn into a major problem during flight. And then finally, after your flight, you want to inspect the battery. Now, it's going to be a little warm from the flight. It's going to be a little bit swollen, but not too much. And with experience and with time, you'll understand how much to expect as far as swelling. Again, you want to check your electrical connectors on your battery, and then you want to safely transport it back home for charging. So I hope these tips will help you have fewer problems in the future. Multi-rotors are somewhat complex, and there's definitely a learning curve involved. So you definitely want to take your time. You want to read all the instruction manuals that come with all your components. You want to follow them closely, and if it's possible, to learn from some more experienced individuals, maybe at a local flying field, or watch us here on Drone TV. We'd be glad to help you out as you progress through learning about multi-rotors.